Now let us solve the second part of this question. The question is like this. Assume that the economy is Keynesian, that is investment expenditure is autonomous and output is determined by the aggregate demand. Okay, so y is equal to c plus I. The aggregate production function is being given us y is equal to a l to the power theta. Okay, a is the productivity parameter and theta is being given us the value lies between 0 and 1. Also we are being told that a firm's employment of labor, that means labor demand, is being found by when we equate marginal product of labor with wage rate. Then the question asks us what will be the marginal propensity to consume. The options are alpha plus beta upon theta. Second option is q upon theta. Third option is alpha. Fourth option is theta. Okay, so let's check it out. In the earlier video we have derived the labor supply. So labor supply we got equal to alpha upon alpha plus beta. Okay, this we got in the earlier video. I will put the link of that very video also in the description box to get the better idea. So let's solve this question. So in the earlier part we have derived this labor supply function. Okay, now we are being told y is equal to consumption plus investment, and production function is a l to the power theta a greater than 1 and theta lies between 0 and 1. Firm's employment of labor is obtained by equating mpl to w. That means the demand for the labor is being found by equating marginal product of labor with wage rate. Okay, so what is mpl then? If this is our production function, then mpl, when we equate it with w, now mpl is the derivative of production function with respect to labor. That means dy upon dl should be equal to w. Now taking derivative of this function with respect to l, so we have theta a l to the power theta minus 1. So this theta becomes coefficient and it is subtracted by 1 by power function rule, and it should be equal to w. Okay, that means let us solve this for l. So l theta minus 1 is equal to w upon theta a. Okay, or l is equal to w upon theta a raised power, when I transpose this it will become 1 upon theta minus 1. Okay, so when I transpose this exponent it will get reciprocated. So what we got here, this is our labor demand. Okay, let me write it here. So this is our labor demand, this is our labor supply, which we calculated in the earlier video. Now let's equate labor demand with labor supply. So this is our labor demand, w upon theta a raised power 1 minus theta minus 1 upon theta minus 1 is equal to labor supply, which is alpha upon alpha plus beta, which we calculated in the earlier video. Now let's solve this for wage rate. I can write it like this: w upon theta a is equal to alpha upon alpha plus beta. Okay, so if I transpose this it will get reciprocated. Okay, so theta minus 1, or w is equal to alpha upon alpha plus beta. We have theta and I can write it like this: alpha upon alpha alpha plus beta again. Okay, I have expanded this term. Okay, so also we transpose this, so this becomes theta a, which gives us w is equal to alpha upon alpha plus beta raised power theta. So if I reciprocate it, it will become alpha plus beta divided by alpha here. Okay, we have theta a here. So this is our wage rate. Now what we do here, we are also being told, so I forgot to write another expression, that was our consumption expenditure was equal to, you know, wage rate times units of labors supplied. Okay, this was also the result from the earlier video, rather earlier question. Now we got this expression here, w is equal to this expression here. Now what we need to do, let us write c is equal to w. We got this very result, so we have alpha upon alpha plus beta raised power theta. Okay, alpha plus beta upon alpha, then we have theta, we have a, this is w, and labor supply is being given us this alpha into alpha plus beta, alpha upon alpha plus beta rather. So here this alpha, this alpha, this alpha plus beta, this alpha plus beta gets cancelled, so c is equal to, we are left with alpha upon alpha plus beta raised power theta. Okay, we have also theta into a, so our c will be equal to, so this setup a alpha upon alpha plus beta, which we calculated it, this comes out to be equal to L. So in place of this I can write L theta, then we have theta times alpha. Okay, so let us rewrite it. So in place of this I have written L, which gives us L to the power theta, then we have theta into a, so our c is equal to, now let us rewrite it. So this is a L to the power theta into theta, and this term is equal to y, so c is equal to y theta. Okay, now what is then marginal propensity to consume? Marginal propensity to consume is equal to derivative of the consumption function with respect to output here, which is y. So if we take the derivative, MPC will be equal to, so derivative of y is 1, so we are left with theta. That means MPC will be equal to theta only. Okay, so I hope I make myself clear in this video. It was not possible for me to write the two questions in this limited space. Okay, so that's why I just try to solve this question in this space, and I have explained the first part of this question in the earlier video. I will put the link of that very video also in the I button. Thank you.